A trillion-mile gas streamer is tilting the planet-forming disk around a young triple star, showing how material from outside can reshape entire systems. This is Fascinating Frontiers, episode 154. ALMA observations captured a narrow stream of gas stretching 0.2 light-years into the gigawatts Orionis system. The streamer appears to be feeding material into the young triple star system from surrounding clouds. This inflow is thought to be responsible for warping the outer planet-forming ring. The data provide the clearest view yet of how external material can alter disk orientation. Follow-up observations will track whether the streamer continues to deliver mass over time. From one striking example of external influence on young systems, we turn to a mission tracking how heat escapes from our own planet's most sensitive regions. NASA's Pre-Fire mission has produced animations showing seasonal temperature changes at both poles over 2 years. The data reveal how heat escapes from Earth's surface through the atmosphere in polar regions. Instruments measure far infrared radiation that was previously difficult to observe from space. The observations help refine climate models that predict ice loss and atmospheric circulation. Continued measurements will track how these patterns evolve year to year. While Pre-Fire watches heat leaving Earth, another space telescope has been looking back at the galaxies that once cleared the early universe. Spectra of more than 1,400 galaxies indicate that a small subset with high escape fractions of ionizing photons drove reionization. The James Webb Space Telescope data show these galaxies had the right properties to clear neutral hydrogen from the intergalactic medium. The result challenges earlier assumptions that a much larger population was required. The paper was posted to EDIREC on July 24th. Additional JWST observations will test whether this pattern holds across other fields. From the early universe, we move to new maps of our own galaxy's structure and chemistry. SDSSV's 20th data release includes expanded spectroscopic observations of stars throughout the Milky Way. The Milky Way Mapper component now covers a much larger volume of the galactic disk and halo. Astronomers can use the new spectra to trace chemical abundances and stellar motions at greater distances. The release adds thousands of new targets observed with multiple instruments. Future data releases will further increase the density of the map. While ground-based surveys chart the Milky Way, a spacecraft closer to home is preparing its cameras for the Trojan asteroids. The spacecraft's instruments are undergoing calibration checks before the first Trojan asteroid encounters. Lucy will fly past multiple asteroids in Jupiter's leading and trailing swarms. Early imaging data will confirm the cameras can resolve surface features at the planned distances. The mission team is adjusting exposure settings based on the latest test results. These tests ensure the spacecraft can capture both color and stereo images during the 2027 flybys. From asteroid flybys, we shift to a new observatory already delivering wide-field views of the southern sky. The image shows a wide-field view of the southern sky captured during early operations of the Vera C. Rubin Observatory. It reveals thousands of galaxies and stars across a single exposure. The observatory's rapid scanning capability will eventually map the entire visible sky every few nights. This particular field highlights the telescope's ability to detect faint, moving objects. Data from these early images are already being used to refine survey strategies. From new survey capabilities, we turn to laboratory work, preparing hardware for the dusty lunar surface. Engineers at Johnson Space Center are testing equipment against sharp, abrasive lunar dust that clings to surfaces. The facility simulates the moon's environment to verify that landers and rovers can operate reliably. Dust mitigation techniques include specialized coatings and seals under development. This work directly supports the Artemis program's goal of sustainable surface operations. Hardware that passes these tests will move to flight qualification. Remember, we covered Artemis yesterday. Today's tests move the crewed landing schedule forward by qualifying hardware for sustained surface operations. From surface operations, we look at the power systems needed for sustained exploration beyond Earth orbit. Idaho National Laboratory is developing nuclear power systems for deep space missions. The work focuses on compact reactors that can supply electricity where solar power is insufficient. Engineers are advancing fuel forms and heat conversion technologies for long-duration operation. These systems would support crewed habitats and science instruments on the Moon and Mars. Testing continues on materials that withstand years of radiation exposure. From power systems, we move to public efforts shaping future lunar rules. The initiative invites public input on protecting lunar sites and resources during future exploration. It focuses on balancing scientific access with preservation of historically significant areas on the Moon. Organizers aim to gather perspectives from diverse communities before finalizing guidelines. The project will feed into international discussions on lunar activity standards. Next steps include public workshops and a report summarizing community recommendations. From policy discussions, we note an exhibition celebrating one nation's lunar milestones. The exhibition marks the anniversary of the UAE's first moon landing attempt and highlights prior missions. It showcases hardware and data from the Emirates Mars mission alongside lunar efforts. Visitors can explore timelines of the Mohammed bin Rashid Space Center's achievements. The partnership with Omega emphasizes precision timing technology used in space operations. The display runs through the end of the year in the UAE. From national achievements, we close with Canada's adjusted lunar robotics plans. The Canadian Space Agency announced plans to redirect resources from the original Canadarm3 design toward broader lunar surface operations. MDA Space confirmed it will support the revised approach with updated robotic systems. The change aligns with evolving international plans for sustained presence on the Moon. Work will focus on technologies that can operate in the lunar environment for extended periods. Details on the new architecture are expected in coming months. The ALMA image of the trillion-mile gas streamer feeding gigawatts Orionis reveals how material from a surrounding cloud can reach a young triple-star system and tilt its outer disk. The narrow stream stretches 0.2 light-years, delivering fresh gas that likely torques the planet-forming material out of alignment. This single observation shows external feeding can dominate disk evolution even after the initial collapse phase. Follow-up observations will track whether the streamer persists and how much mass it ultimately delivers. What fraction of other young systems experience similar external tilting events? A gas streamer 0.2 light-years long is roughly the distance from the Sun to the nearest star system beyond our own. Yet it remains narrow enough that it could thread between two neighboring solar systems without touching either. Picture riding alongside one hydrogen molecule as it travels that entire length. It would take thousands of years at typical cloud speeds, all while staying confined within a channel only a few hundred astronomical units wide. ALMA's radio observations show this channel is actively delivering fresh material into the gigawatts Orionis system, where the incoming gas carries enough angular momentum to twist the outer disk. The mechanism works because the streamer arrives from a different direction than the original cloud core that formed the stars, so its momentum vector is misaligned with the existing disk. We can measure the streamer's mass, flow, and the resulting warp angle, but nobody yet knows how often such streams occur around other young multiples, or whether they are the main reason some disks end up tilted. Before we go, keep an eye on upcoming JWST observations that will test whether the reionization pattern holds across additional fields. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. One more thing. If you liked today's episode, our sister show OmniView is worth a spot in your feed. A balanced daily world news briefing that takes every side seriously. It's one of the NARA Network's daily briefings, all free at naranetwork.com. Prefer reading? Today's full write-up, sources, and transcript are on the episode blog at naranetwork.com. Alma Observations blog at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting